Hello, everyone. Thank you for joining us for today's webcast. It's Top 5 Log Analysis Mistakes. I'm Catherine Barrett with O'Reilly Media, and today's presenter is Dr. Anton Chuvakin, a recognized security expert and book author. His current role is Chief Logging Evangelist with LogLogic, a log management company. He's an author and contributor to several security books, including O'Reilly's Security Warrior, and several books with other publishers, Know Your Enemy 2, Information Security Management Handbook, Hackers Challenge 3, and PCI Compliance. Anton has also published numerous papers on security issues and is an active blogger. You can see securitywarrior.org, and he blogs on the O'Reilly Network also. And he's a frequent speaker at security conferences. He participates in various security industry initiatives and standard organizations, and he is an expert on the topic he's speaking on today. Now, in just a moment, I will turn the presentation over to Anton.
First, do a quick introduction to logs and login. Again, I did say that I don't think my O'Reilly audience needs a detailed intro to login, because most of you, I'm sure, have to deal with logs at least once or more than once in your life. At the same time, the establishing the common ground is important in this area because there's so many opinions and so many different views in law. Then I would go and cover a few bits in what I call my motivational slides for why looking at log. Similarly, some people might not need any reminders about the importance of logs, but at the same time, many of my audience who might be new to the field would probably find it useful, at least for convincing their bosses. Afterwards, I would do a quick review of today's log analysis methods, just to establish the views on mistakes and other things that I will show next. So, on this slide, you'd see that if you look at the picture at the right, in the left side, and that's your idea of logs, then you might really be in the wrong presentation. At the same time, my background on logs would probably make it useful. So, what this slide shows that there are all sorts of different log types from all sorts of different sources. And I really advocate, and I would suggest you guys also advocate the same view of logs, namely a very broad view. Don't just focus on any individual type of logs. For example, only syslogs from Unix, or only Windows event logs, or any other specific single log type. Because many of the logs share the same properties, and they're also serving the same purpose, whether it's the database audit trail, Unix syslog, or Windows event log. At the same time, on the right, I have the data sources that produce logs. At this point, I cannot really say that one can create a full list of log sources, because there are so many different ways to create logs, and there are so many different reasons to create logs, that all those are important, and there's probably an even longer list of things I didn't mention here. Now, this slide illustrates why so many people are confused about logs and login. Now, these four messages for a log record really say the same thing. Now, notice that the first one says logged on, the next one says login success, the next one says accepted password, and the final says account logon. Now, these four different systems really are trying to say the same thing, that the user has access to the system. And the interesting fun part about that is that even sometimes the products from the same vendor or from the same software company would not even agree on how to log things. Now, certainly Linux and Windows wouldn't agree on how to log things. But at the same time, if you look at some of the products from individual large companies, you'd see major differences in how even such trivial things as user login are recorded and logged. And this type of stuff is what gives login such a bad name, so to say, why people prefer to either pretend login doesn't exist or prefer to store logs and never look at them. So that's the common, upon seeing those messages, even if something as simple as user login can be recorded in so many different times, people tend to jump to this conclusion, hey, why don't we just ignore them? Now, this is what I call my motivational slides, and as some people humorously note, it's 2008, so no presentation is valid without mentioning compliance. Indeed, many of the regulations that we have today do mandate logs and login. Some of them directly prescribe logs and login, while others prescribe things that are unthinkable without login. Now, there are many regulations, and I don't have time or the scope in this presentation to cover them. The main idea here is that a typical regulation today that covers IT or IT security environment would say that you have to have logs, You have to collect them, preserve them for a certain period of time, and you have to review and protect them. Best example that I can give is really the PCI DSS, so Payment Card Industry Data Security Standard, that applies to those companies or organizations that handle credit card numbers. PCI has a specific requirement about login that says that you have to have logs, record specific activities, protect audit trails, so store them for a year, as well as review them. This is pretty much what people need to do with logs. Other regulations or best practices, so to say, also mandate logs and login, as you can see on the right side and on the left side. So at the same time, when we established our motivations for logs and login, I will spend a few minutes reviewing how people actually do it. Now, there's certainly a whole field of trying to make sense of that type of diverse data for all sorts of purposes. But I would try to squeeze everything that I know about log analysis into one slide. And here's that slide. Now, everybody who ever dealt with systems or system administrations or protecting networks or systems would know that if you really have to, you can go and read the logs by using tail or more or grep on Unix, or by launching a notepad or Windows Event Viewer and Windows. Now, you can certainly read a few kilobytes or a few hundreds of lines of logs. You could probably do a relatively good job if you have megabytes of logs. Now, if you have gigabytes or much less terabytes, certainly reviewing logs manually would never work, and we can pretty much forget about this method. Now, as we go down the slide or up in technology sophistication, some people would try to say, let's try to throw away everything we don't need and just look at the important record. So the challenge is that we don't know what records are important in logs, and one of my mistakes further in the presentation would explain that. A very good approach was suggested to throw away all the records we know we don't need, and then look at the rest, which goes back to Marcus Raynham artificial ignorance approach, or negative filtering. That works much better on log data. Now, everybody who ever dealt with a commercial log analysis or log management product knows that those have good reports and views and charts and all that stuff, which is pretty much amounts to summarize the logs. Top users of firewall, top users of a system, top connections from a firewall, top attacking countries or something as humorous from a security product sometimes. All those are summaries of log data. And some logs are easy to summarize. You can see sources, destination, IP addresses, and other stuff, while others are really hard to summarize because they're pretty much normal English text or sometimes broken English text. For example, if you look at Unix syslog, you can see all sorts of humorous and obscure messages that really mean nothing and cannot be summarized. Now, as we go down the slide further and look at more high-tech approaches, we should certainly mention log visualization, trying to make pictures going from as simple as a bar chart to as complicated as a tree map or some other visual representation of logs. Now, I think that the amount of research spent on that area is a little incomparable to the amount of results we receive. So you can imagine that I'm not a major fan of visualization, even though I know some people who are spending pretty much years developing new approaches for log visualization. In many cases, a table or a flat file view of a log might actually be more handy than a sophisticated picture. Now, to those logs that are more like text or like English text or pretty much any other language text, several approaches have been developed to index the logs and to make them searchable much faster than you would have it with a grep or a simple tool to go through logs. Now, why is it important? What's important here is that some logs really don't look like data at all. Some of the examples that we saw on my Logon slide would tell you that it's relatively hard to establish different pieces of metadata or parameters in those logs, but it's just much easier to just read them. For those types of logs, sometimes we can pretend that they are just normal text and try to understand them as text by indexing and maybe using other techniques for text analysis. Similarly to the above, people who looked at commercial tools to do log analysis and log management would certainly know the word correlation. That's a little overused at this point. Many people try to create a set of rules or other patterns to go across log data and to automate the analysis of logs. And that's worked with moderate success, even though this approach typically requires a fairly heavy burden of creating those rules for log analysis, whether done by the vendor or by the customer. And final line on this slide is my favorite method, which is unfortunately the least developed at this point, trying to use data mining or maybe even text mining techniques to automatically make sense of log data. I do have a separate presentation that covers use of data mining techniques on logs, which is really out of scope today. I would just add that it's my favorite approach because it has the biggest promise of relieving the humans from having to go through log data and understand it every single bit. Before I go into mistakes, I want to take a quick glance at a bigger picture of logs and logging. I did say that some of the regulations, whether it's PCI DSS or others, mandate logs. But logs really fit into three large domains of our knowledge. Now, if you run systems, if you run Unix systems for a living or Windows systems, you'd certainly be familiar with the bottom part, namely system and network troubleshooting. If something fails, go look at the logs type of approach. And at the same time, the top part is also well known. If you have to respond to an incident, how do you know who hacked what, how was it done, how long ago did it happen, as well as answer other incident-related questions, you look at logs as well as other sources of data. Now, the middle part is a relatively modern invention compared to the other two, namely some of the laws and regulations just directly mandate logging. They usually do it so that you would be compelled to collect and analyze logs for the remaining two purposes, namely for the security and operation. At the same time, many people now look at log analysis and log management tools mostly for the central part, because the auditor might show up and say, hey, how are you looking at logs? So all this might sound complicated. So no wonder people make mistakes. At this point, I'm going to transition into the main part of my presentation, namely log analysis mistakes. And I would just show you the mistakes up front. Somebody has to ask at this point, why is there mistake number 0? How come is Anton that geeky so he numbers mistakes from 0 and he counts actually 6 of them, not 5? Well, there's a story to go with that. In fact, I used to have a presentation that was about 5 log analysis mistakes, because the idea of people not logging was completely unthinkable to me. I was pretty sure that everybody in the world would pay attention to logs and treat them seriously. Now, as I noticed more and more things and how things are done, I noticed that I really have to stick this mistake number 0 up front because if you're committing the mistake number 0, you really have not having a chance of dealing with other mistakes. So let's go review them in detail. So not logging at all. Now, I don't really want to spend that much time on this one because I really hope my enlightened audience here at O'Reilly would know that logs are important for all sorts of purposes. And if some of you weren't, go back and look at motivational slides in this presentation. However, I did say that the idea of people not logging was unthinkable to me. Today, however strange it might sound, some of the systems that we need to look at logs for are actually not that well equipped for logging. And committing this mistake actually became more likely, not less likely. It does sound counterintuitive, and here's the answer why. Maybe 3-5 years ago, people didn't even think about looking at logs from databases. We all were looking at the Linux systems, Windows systems, sometimes at web proxies, web servers, and these were pretty much the big three of logging, maybe operating systems, web servers, and firewall. Now, as we delve more into data, we do need to collect logs from systems that collect and store large amounts of databases. If you happen to read the documentation for Oracle, for example, or any other major database, you'd know that it has a dizzying array of different logging options. There's actually a way to log all sorts of actions in a typical enterprise database today. However, when you buy this database and when you deploy it, it actually comes with most of the logging options turned to off. In fact, the default login on a typical database, be it Oracle or Microsoft SQL Server or any other database, would actually be pretty small. It would actually be limited to major events in the life of a database, such as restarts, specific types of the DBA or database administrator access, and pretty much nothing else. So where is data access audit? Where is the change audit? Where is the configuration change audit? Well, they can all be enabled, but they have to be enabled to be present. So today, as we look at applications and databases, and the logs from those systems, there's actually a higher chance of committing a mistake of not logging. Because think about it. There's almost nobody who would deploy a web server and then turn login to off. Specifically, if you have an Apache deployed or any other web server, you wouldn't go into the configuration file and say, I want my login to stop. This is kind of unthinkable. At the same time, if you deploy a database, you really need to go and read up on login and figure out how to turn it to on. So some people just leave it at off. That's committing my mistake number 0. Going further down the list of mistakes, we're getting to mistake number 1, namely not looking at logs. Now this sounds kind of simple. If you collect logs, surely somebody would look at them. But when we think about terabytes, or I wouldn't be surprised if we would talk about petabytes of logs in the near future, many people tend to take a shortcut and say, I need to pay attention to logs, so fine. I'm going to collect the logs, tape them somewhere, and stick this tape in a tape closet, and I'm done. I'm done my log analysis and log management. I'm done with my log analysis and log management. This is certainly committing a mistake because logs are all trying to tell you something, and unless you go look at them, you're committing a mistake. Typically, there are 2 choices here. People who don't have logs really stuck at the mistake number 0 level. People who do have logs have 2 choices. They can either review the logs after an incident. If something breaks, they go and say, well, let's look at logs. If you paid attention to them and you collected them, at least you have a chance here. Now, a more enlightened option would certainly be an ongoing review. Usually when people hear me talk about this, they say, well, this sounds kind of obvious, and it's all easy to say, hey, look at logs, and you can keep harping about that. But we have 50,000 systems that all produce logs, and we have many firewalls, and we have other types of log sources. So it's easy for us to hear you say that, but how do we actually do it? Well, that's a good question. How do you eat an elephant? Well, you eat it piece by piece, of course. How else? So the best way to start making use of that data you collected is establish the priorities, which are driven by either your security policy or by whatever risk assessment that you performed. And this is an example log review priorities from a certain company that decided to focus on using logs for the external threat protection or protecting against hackers that might have broken or might break into their website and disrupt operations or steal data. So this was driven by their individual risk assessment. Other companies might choose to do quite the opposite. But let me explain how this was created so you can actually repeat the same process in your organization and thus avoid this mistake. This company decided that they would need to use logs to figure out whether people are attacking their exposed and publicly exposed resources, web servers, application servers possibly. So they decided to focus on logs from the systems in the DMZ, or demilitarized zone, which is the outward-facing part of the network. What they had there is network IDS or an IPS for monitoring, as well as some protection. They had a firewall that would record connections to the servers in the DMZ, and they had the actual servers. So first, their analysts decided to look at IDS logs, because after all, if you deploy an IDS and you're not looking at logs, you're certainly not using your investment wisely. And at the same time, there's plenty of documentation from the IDS vendor typically on how to deal with logs and what they mean. Now, after they established the first step and they started looking just at those logs and leaving the rest be, they said, well, what's the perfect complement for IDS logs? Well, these are the firewall logs from the same part of our infrastructure. So they started involving the firewall logs and tracking connections and seeing what happens, usually using summaries, like top connections to our servers, top connections from the DMZ, which really should be empty. And then from that point onwards, after they established these two, they said, well, how about actual servers? Let's see what's going on the actual servers here. And they started including the server logs into their log review routine. So they really did it kind of piece by piece. Now, when they started doing the review of the server logs, they hit a bit of a snafu. Namely, they all knew how to analyze the IDS logs, and they learned how to make sense of their firewall logs. But there was nobody who would explain to them what those applications logs mean. So this is where the project was certainly hitting some trouble points, because there's much more documentation and resources on what to do with IDS and firewall and server logs compared to application logs. But still, they needed to do it, and they decided to go along with that. Now, further, after they started reviewing those logs, they went further down the list and started looking at some internal server logs that the data protected, but at the same time might have housed more useful, more valuable resources. And then right now, this company is probably somewhere at step 7, where they're trying to look at other application logs and other resources which are internal to the company. So doing this actually helps you start up with the log review process, as well as not get drowned in the whole ocean of logs. Now here's one of my favorite mistakes, and here's one of my favorite challenges to solve as far as logs are concerned. Storing logs for too short a time. When I speak and present about logs, usually at least one person in the audience would say, so tell me, for how long should I store my logs? And usually there are no additional details volunteered to me. What logs, why is he interested in logs, what sort of motivation factors are there? And this question is certainly unanswerable. I did say here on this slide that it's a hard one. It's really not a hard one. It's an impossible to answer. I've heard all sorts of bizarre estimates ranging from, well, you must keep logs for 7 years, or only a few days is enough because I don't really have any more disk space, or even until the disk runs out. So responding to this question is a fairly hard challenge. And so I would explain, I will give you a strategy or a sort of a workflow of how to deal with this one. Now, in the bottom part of the slide, you see my estimate, which is fairly common nowadays, and this number is actually growing towards larger, maybe one year retention. Now, this is driven mostly by regulations. If you're using logs mostly for troubleshooting, there's no chance that you'd use a 3-year-old log for troubleshooting. They might be somewhat handy for incident response, and they might be handy to show the auditors, but there's certainly no operational use of logs beyond a few days or a few weeks. But here's something really interesting about this mistake. It has a counterpart of storing logs for too long. Now, I personally was surprised when some people told me, well, you're telling us that you need to store those logs for quite some time, but that's actually illegal in our country. And after my initial shock fizzled out, I did delve deeper into some of the privacy regulations, which are mostly known in Europe. And I was pretty surprised to find that some of the countries actually treat log data as confidential. They treat them as private information, even if logs contain just an IP address. So here in the U.S., we don't treat IP address as public information, it's as private information. If you run a web server, you certainly collect the logs, and it would seem that you're collecting private information about your visitors if you follow those guidance. At the same time, if you work for a large company that has offices in Europe and other countries, there's a good chance that some of the privacy regulations will affect your logging. And you'll have to enforce not only the retention, not only the storage part of the retention policy, but also the destruction part, that the logs would really be gone after the time that you're allowed to keep them. And I've seen some specific numbers. For example, I don't remember what the name of the country was, but in one of the countries you're only allowed to keep logs for a few days if you're a service provider, if you're an internet service provider, because you have to justify that you have operational need for this log collection. In this case, none of those 90 days or 1 year retention period would ever work. Another factor that would affect, which would push the log retention policy towards shorter time frame, is actually your legal team. In a couple of places, I've seen that lawyers would say that logs are really a way for others to sue us, and they were heavily anti-logging early on because they were saying that we should not be keeping all this evidence against ourselves. Now, this might sound like a humorous approach to most IT people or to most IT security people who know that logs are important. At the same time, this might actually lower the typical retention policy for logs if legal team is involved in the process, and they should be. And clearly, resource utilization, those tapes and disks, aren't unlimited, even though they might be cheap. So this might drive some of the log retention factors towards smaller periods of time. So how do you get out of this one? How do you solve the log retention challenge? Now, I wish I can give you a simple answer, but I can only give you an example strategy that you can use for your own environment. and figure out what to do and how to follow it. So this is another example strategy from a company that wanted to get organized as far as log retention and log collection and log retention. And they went with this, what I call the three-dimensional approach. They looked at the type of a log, what type of a log source. They looked at where from their network the logs would come. And they looked at multi-tier storage, in this case a two-tier storage. The log management system was the online tier, and the tape backup rack was the archive tier. Now, one can also imagine a three-tier storage with online, then nearline, and then offline storage. But in this case, it was simpler, and they chose a two-tier approach. So to build their log retention policy and to justify it for their management as well as potential external auditors, they just went and focused on how they use the logs, what regulations would affect the login or the specific log source, as well as available resources. So for IDS and IPS logs from DMZ, they decided to keep them online for 90 days because a typical use for such logs would be investigating an incident that involved a hacker or some other attack against the website, which is typically known within days. Now, they really wanted to keep the firewall logs from the DMZ systems for the same 90 days. But what you notice, the number here on the slide is 30. Here's where the real world barged in and pushed the requirements down just because of sheer resource utilization. They did not want to spend much more money on storing firewall logs for 90 days and decided to limit them to 30 days. At the same time, they wanted to keep the logs from critical internal servers online for 90 days for investigative purposes as well. Now, beyond that, they decided to go with tape, and tape, as we know, is cheap, so they decided to tape all the DMZ logs for 3 years flat out. Now, this would, for many companies, it would amount to a lot of tape. At the same time, this company decided to go with that because they, from a couple of incidents, learned the value of logs and login and how logs might be handy even sometimes years after an incident. Now, the most interesting piece of this example strategy is actually the line above the bottom line, namely critical servers, internal to their network, and tape storage in 5 years. Now, 5 years is a long number, is a large number, and that would amount to a lot of logs. But this number is driven by the fact that for some of the information leaks and insider incidents, there's often no knowledge of an attack or no knowledge of data theft for months or years, and there is, after the incident is discovered, there's a lot of need to actually gather evidence and prosecute the person or to build some kind of a case against him or her. Now, this is where the large retention period on tape comes in. They don't want to spend time managing those logs online in a log management system, but they did want to have those handy. So that drove the relatively large number of 5 years. And then finally, the bottom line shows that for other internal servers, they decided just to tape the data for 1 year and then throw it away. Because again, resources, other usage of their storage systems was more better justified. And notice that this company was under no privacy regulations. So there was no downward pressure for the retention period. So they pretty much, the security team got what they wanted here. And following the same approach in your environment is actually a pretty good idea. You might have more complexity or less complexity than that. If you're a small company, you might go and save all the logs for 30 days in an online system, and this might still not go beyond a few dozens of gigabytes or a few hundred gigabytes. Now, if you're a very large company, you might have a much more granular view. You might say a specific type of a firewall from this region will be stored online for that many days, while all the other firewall logs from all other regions would be stored online for maybe a much smaller number or much larger number because of no privacy regulations. At the same time, this at least gives you a structure of how to deal with this elusive retention question. Now, here's the most controversial mistake that I would present today, which is the mistake number 3. I would say that deciding what's relevant before you grab the logs is actually a mistake. Now, this is where all the questions with, can you really collect all the logs, Or can you really store all this data? Or is it not impossible to collect all those terabytes of data? Comes into the game. And I always counter them by saying, well, could you really know what logs you'd need tomorrow? And the answer to this is, unless you get some kind of an extrasensory perception powers, or maybe an ability to see the future, the answer is no. Now, it is certainly not simple to get every single log record and to store it. It is certainly not, you're not doing it because it's simple. You're just doing it because the opposite is actually harder. Now, some people counter this by saying, well, surely you're not saying that all logs are useful. You know what? I'm really not saying that all logs are useful. What I'm saying here is that you don't know which ones are useful unless you have them in storage. Now, this one, how do you really do that? How can you do that? How can you hope to collect all the logs and still not drown in this whole vast sea of data? Now, this is clearly a gross oversimplification here, but at least it gives you an idea that just because you enable log on your systems and collect most every log record and retain them for long enough, it does not mean that you would have to be working over time analyzing the data. What I advocate here is that you do have this tape or this system storage device that has all the logs in their raw and modified format. So if you have to go back for incident response or some kind of forensic investigation or e-discovery request, you actually can do it. I'm not saying you have to read every single log or much less act on every single log. In fact, you might not even be summarizing all the logs, but you have them, and you know that you can go back to it and review whatever happens to your environment. Now, admittedly, this might not be the answer on how to do it, but that answers the key question: what is better? To collect some of the logs based on some kind of an upfront idea of what I would need, and then notice that you would need something that you didn't collect, or to go and spend time on collecting most of the logs, retaining them, and then being relaxed in their opinion of confidence that you have them and you can go back to them. As I'm moving down the list of mistakes, here's another fun one. When we build a log management infrastructure, when we start log analysis projects and we start to review logs, we'll often go through what I call the natural logging order in the paper. So people say, well, firewall, yep, we definitely collect logs. We look at those PIX records and checkpoint messages and other stuff. Linux, Unix, certainly. Syslog is aggregated on a server. We index them. We run correlation. We do other stuff. So it's taken care of. Windows, it's a bit tricky, but yeah, we collect them. We do analyze them, and we make sense of them. And certainly the same can be said about the IDS and IPS. Now, when we move towards the application realm and look at databases or all those enterprise apps, the answer becomes less certain. Oracle, login, what kind of logs are there? And people start to be less certain about their log collection, log analysis infrastructures. When we move to enterprise applications, the answer becomes even less certain. And then finally, when we hit the bottom of, well, your internal IT team wrote that application and it handles critical data, what kind of logging is there? And the answer to this is often, sadly, well, there's none, because we didn't even know what we would need, so we didn't mandate anything. And there are plenty of excuses that people bring up for just looking at firewall logs or just looking at server logs, because there's no expertise and they don't know what to do with them. And there's certainly enough pressure to actually keep it that way. Why is there pressure to ignore application logs? Well, an oversimplified answer to this is that because they're ugly. Because they're not just ugly in an aesthetic sense, but they're ugly because they often don't tell you anything, or they don't tell you what you need to know. Now, this example is a jumbled mess of application logs, so to say, from a common enterprise app, which has all the key login mistakes or log creation mistakes. It uses numeric codes, it lacks priority, and it has all sorts of other strange issues with unexplainable or inexplicable logs that aren't even documented. So if you have to deal with that type of data for your incident response, there's a good chance that you'd hit a dead end, whether you have those logs or not. Now, I do see that in the future, as logging standards are coming on board, there will be much more structure in those application logs, as well as there would be some clear guidance developed for internal developers who create applications that log. And most every large-scale application would have logging options. So I do have some high hope for the future as far as the application logging is concerned, mostly coming from the standard side. I'm involved in the MITRE CE standard and have a chance of creating such guidance in the near future. Now, my final mistake here is approaching logs as some people approach intrusion detection. Namely, they say, well, give me the list of all the bad logs. Just give me the list of all the bad messages, of all the bad log types that I need to look for, and I would be happy, because I would be able to just not set some kind of a system that would send me alerts if I see those logs, and then I'm in a good shape. Now, this approach might have worked somewhat for intrusion detection and prevention people, but it totally fails for logging. Why does it fail? Because it's not often that you know what the bad logs are, and even the firewall connection message that somebody connected to port 80 might be good or bad based on the direction, on the source and the destination, and even on what else happened in the environment. So ideally, we would want to have not the bad messages, but really the messages that we are interested for. The best example, or the simplest example, of not falling to this mistake is that negative filter and artificial ignorance approach that I mentioned early on. This is where you look at logs, you notice what logs you certainly don't care about, you throw them away, and then you review the rest. And there are much more sophisticated ways to deal with this, and I really have high hopes for data mining technology as a way to improve this. At this point, I'm ready to completion, and instead of conclusions today, I will just show you the same mistakes to remind you of what we just covered. Not logging, not looking at logs, just having them lie there in cold storage without any use. Storing logs for too short a time, as well as storing them for too long a time. This is where the privacy regulations come in. Prioritizing or deciding what to grab before you grab it. Now, this is not simple to avoid. The answer here is that this mistake, in my view, is a greater of two evils. If you decide what to pick before you pick it, there's a good chance you'll miss the logs you'd need for your investigations and other uses. And ignoring logs and applications is very tempting, because a lot of application logs are really pretty bad. And at the same time, there are efforts underway today for making the world of application logging better. And I do have high hope for future application logs to be more useful for analysis. And then the final mistake that I just covered was looking only at bad stuff, or known bad messages. Give me the list of bad web server logs, or give me the list of bad attacks, and I would just ignore the rest. This rarely works for logging. Now, this is certainly needed, and you certainly need to do that, but only looking for known bad is not going to get you that far, because many of the log messages are only bad in context if you look at other logs, or if you consider other events happening on the systems. And this is pretty much the story for today, so I'm going to go review the questions that were asked.
Anton?
Yes?
It's Catherine. You might want to keep that last screen up there. There haven't been any questions yet, but we'll ask the audience if you have any questions for Anton. I thought that was a fascinating
Oh, yeah, absolutely. If you have any questions, definitely send those over at this point.
Yes. And we'll just wait a minute. Someone's asking if you'll...
And at the same time, I'm actually pretty easy to find. So if you have any questions in the near future, you can send me an email or reference to this presentation, and I would send whatever responses or comments I have.
Great.
Also, while I'm on the slide, it makes sense to check my blog for more logging resources, because, as you can guess, one of my favorite blogging subjects is logs. So if you go to my blogspot blog mentioned here on the screen, you can see a lot of interesting information about log management, both in the process and program type, as well as technical. For example, how do you use proxy logs for detecting the document uploads and sort of the poor man's information leakage detection.
All right, someone said it's already in his or her feed reader, so great presentation. You're
okay,
a lot of,
perfect. Looks like I did start some thinking about logging and logging in my audience.
Yeah.
If there are no more questions, again, I'm easy to find, so feel free to drop them over email or other means.
Oh, people are asking if the presentation will be posted. I don't know if Anton will make his slides available, but we do record the presentation, and I will send you, we record it as a movie, and I'll send you all a link once it's available. That should be probably in about a week.
And also, I post most of my presentations in SlideShare, and so I would post this slide deck on SlideShare, and I would share a link on my blog, or I can also send it to Catherine so she can post a link on the O'Reilly website. So this presentation will be available on SlideShare, and at this point you can just go to SlideShare and look for my presentations. There will be plenty others, including the one on data mining that I mentioned. As far as this present, I would post it in probably a couple of hours and send a link to Catherine.
Okay. We'll have the link available for you. Someone's asking where will it be, what URL. You can check Anton's site. It's up on the screen right now, or I will send you all a link once it's available. Once he sends it to me, I have everyone's email address that you registered with. And there don't seem to be a lot of questions forthcoming. I thought
okay,
it was an
that's cool.
excellent
That's perfectly fine then.
Okay, well, thank you very much, Anton, and thank you everyone else for joining us. And,
thanks for inviting me.